In this video, we're going to look at frequency tables, and levels of measurement. We're going to use very basic vocabulary when we're talking about the levels of measurement for variables. So when you read or you hear somebody say this vocabulary in reference to a statistic, you'll know what we're talking about. We're going to construct a frequency table, and we will include relative and cumulative frequencies. So you've collected your data and now you want to organize it so you can determine how many pieces of data occurs in each set. So each datum, which is a piece of data, occurs in each set. When you're calculating the frequency, you're going to want to round your answers at the end, and you want to do it and be as precise as possible. The rule of thumb usually is to carry out your calculations out to twice as many decimals as the actual final answer. So say your final answer should be 2 decimal places, all your intermediate steps in the calculation should be about 4 or 5 decimal places. Now if you're using a calculator, this is not a big deal. If you're using a spreadsheet, again, this is not a big deal because it will round as many as you ask it to round to. So when we're talking about the levels of measurement, we're talking about the way this set of data that you've collected is measured. So we're going to talk about the levels going from the lowest level of measurement to the highest level of measurement. So we're going to start with a nominal scale. Now this classifies data into mutually exclusive, in other words, non-overlapping categories. And you'll have a certain set of categories. You won't have an infinite set, you'll have a finite set. There's no order or ranking that can be imposed. It's qualitative data. No calculations can be performed on nominal data because it's qualitative. So gender or zip codes, political affiliations or religion, you're just collecting the data. You can't actually do a calculation on people's religious beliefs. You could do calculations on how many times people said that they were a certain religious belief, but you can't do any calculations on their actual religious belief. The next level that we're going to look at is the ordinal scale. This classifies your data into categories. This is usually qualitative. So you have a ranking now, but the precise differences between ranks do not exist. So addition or division do not make sense in this. So letter grades, an A, a B, a C, a D, or an F. Now that's different than if you are on a 4.0 scale. So if you're on a 4.0 scale, it would not be an ordinal scale. But the letter grades from A to F have ranking to them, but you can't do addition or subtraction or even division on this. The judging of a contest between first, second, and third place. Your ratings, above average, below average, exceeds, below average, poor. So that's the ordinal scale. The interval scale is now we're going to talk about quantitative data. So things that we can actually do, perform addition, subtraction, division, and all that kind of stuff on. So we have ranks in it. And precise differences between units of measure do exist, and they are meaningful. There is no meaningful zero. So on a position of scale, it does not mean an absence or something of. Zero is simply just a placeholder. So temperature. So temperature is one of those things that is rankable. It's quantitative. But zero does not mean that it does not have any heat. It just means that it's like a placeholder. It's a zero temperature. It does not mean that it doesn't have heat. IQ scores, nobody has, if you're doing an IQ of a person that is alive, zero does not have any meaning there. And calendar dates, right? So calendar dates is another thing that can be ranked. Now we're going on to a ratio scale. This is quantitative, so we're talking about numeric values that we can actually do addition, subtraction, multiplication, division on. We are going to rank our data. There's going to be a precise difference, and it exists and it's meaningful. You're going to have a true zero. I mean, zero means absence of something. You can add and subtract and multiply, divide. So height and weight and area and the number of phone calls received, person's salary. So if I'm trying to determine whether or not this is quantitative or qualitative and then determine its level of measurement, the first thing I'm going to think about is this something I can count or is this something I can measure? So that's really, for me, the biggest decision making of whether or not it's quantitative or qualitative. Can I count it or can I measure it? And what I mean by that is, so if I'm talking about number of phone calls, I can count the number of phone calls, but I can measure their length. So those are two different types of quantitative data. One is I'm counting, and one is that I can actually measure how long it is. And then for qualitative, I want to think of this as a yes or no, or person's beliefs. So that's qualitative. That's how I make my decision about whether it's qualitative and quantitative and the levels of measurement. So my first one here is I have a free throw shooting percentage of a basketball player. So this is something I can count, so it's quantitative. And since I want a percentage of a basketball player, it's a ratio. A survey to response, are you predominantly left-handed or right-handed? So this is asking not necessarily a yes or no question, but they really only have two choices. It's a binary left-handed or right-handed. And I would make note of whether they're left or right-handed, and I'd make a tally of that. And so this is qualitative, and it's nominal. The temperature in Fahrenheit in Atlanta, Georgia. So this is something I can measure. So it's quantitative and it's interval, because when I'm talking about temperature, it makes no sense to do division. So that's why it's not ratio. So this is quantitative and it's interval. Individual page numbers at the bottom of each page listed in a book. This would be somewhat like an ABC kind of thing. So this is qualitative and it's ordinal. Now we're going to look at frequency and frequency tables. So here's some vocabulary. Frequency is the number of times a value of a data occurs. So like I said before, if I was talking about the left and right-handed, I would be then doing a tally. So I would talk about the frequency of somebody saying they're left-handed versus right-handed. Cumulative frequency is the accumulation of all the previous frequencies. To find cumulative frequency, we're just going to add the previous frequency to the current frequency that we're looking at in that row. Relative frequency is a ratio. It's a fraction or proportion of the number of times a value of the data occurs versus all of the outcomes and the total number of outcomes. Cumulative relative frequency. Now, this is not the same thing as cumulative frequency. It's the accumulation of the previous relative frequencies. And when you get done, the very last row should have 1 in it when you're doing the cumulative frequencies, just like the cumulative relative frequencies. When you're looking at cumulative frequencies, the very last row should have the same number of data pieces you have, should be in that very last row of the cumulative frequencies. Cumulative relative frequencies should have the number 1 in the very last row of the data pieces. Class width or class interval. You might also talk about it as the bucket. You're putting this information into, quote, a bucket. And it's the difference between the upper and lower boundaries of any class or category. To calculate this class width, we're going to subtract the starting point from the ending point and then divide by the number of classes that you wish to have in your frequency table. So as an example, if you have 150 data values, one of the ways that you could do this is you could say, okay, what is my lowest? My lowest is say 10. My highest is say 15. So I think I'm going to put them in buckets of 1. If my lowest one was 10 and my highest one was 35, I might have buckets of, say, 5. So I'd have 7 buckets or 7 classes. If the data values are discrete and there are not too many values that are different, a width that places the data values in the middle of the bar or class interval is the most convenient. A guideline that is followed by some textbooks is to find the number of bars or class intervals is to take the square root of the number of the data values and then round to the nearest whole number. Now we're going to be using spreadsheets for most of that. So with our spreadsheets, we can make a decision about how many we want, and it back end calculates this if you don't tell it how many you want. So what it does is it says, okay, so there's 150 data values. You're going to take the square root of 150. You're going to round, and that gives me 12 bars or 12 intervals or 12 classes. The class midpoint represents the precise value located in the center of each class. It serves to represent the point of understanding of the distribution within that interval, and we will use the class midpoint for other calculations in this class. By calculating the class midpoint, we can gain an insight to the central tendency of the data. In frequency distribution, class boundaries are the values that separate the classes. This is how we would find these class boundaries, is we'd subtract the upper class limit, that's the top of the class limit, from the first class, from the lower class limit. So what I'm talking about is, let me tell you. So if I say I have a class that goes from 10 to 12, okay, then the upper class limit would be 12, and the lower class limit of the second class, so say my second class goes from 13 to 15, then I would take the upper class limit from the first class, which is 12, and subtract it from the lower class limit of the second class, which is 13, and then divide by 2. So I would have my class boundary for this one would be, say, 10 to 12.4, and then the next one would be 12.5 to 15.4, and that would actually be my class boundaries. And that, so when I say my class is from 10 to 12, in some cases, if I have 12.4, I've got to figure out where I'm going to put that. So if I have 12.4, because I've decided what my class boundaries are, I'm going to put it in that first class or the first bucket. The upper class limit is the highest value of the interval, of the class interval. The lower class limit is the smallest value, which is what we talked about. So now let's go through an example. So we have this study that's done by a pharmaceutical company, and they want to determine how effective their treatment program is. So they're going to be testing an AIDS antibody drug. They're going to give it to the patients once the AIDS symptoms have been revealed, so once they started showing symptoms. Of interest is the average mean length of time the patients live once starting the treatment. My assumption is that they're trying to prolong people's lives. Two researchers follow different sets of 40 AIDS patients from the start of the treatment until their death, and this is not uncommon to run 2 different studies simultaneously so they can compare their results. So here's the data that we've got. We have researcher A and researcher B, and we want to, and this is already filled out for us, so we don't have to worry about the class intervals. It's already been filled out. So you can see the class interval here is 0.5 to 6.4 and then 6.5. So what I know is the class boundary here would be 6.5 minus the 6.4 and divide that by 2, and that will tell me where I'm actually going to put this for. And then I'm going to start filling in the frequencies. So what I would do is for researcher A, as I would say, okay, I have 3, that's going to go here. I have 4, that's going to go here. I have 11, and that's going to go here. And notice how what I'm doing is I'm just doing tally marks. I'm just figuring out how often any of this happens, and I'm not putting the actual numbers, the 3, 4, and 11 in here. I'm just doing tally marks, okay? So I've done this already, and I'm just going to put those numbers in there. You should check it yourself. I have 2, 5, 9, 5, and then my paper goes on to the next 7, 7, 2, and 3. Now my cumulative frequency would be 2, and then right here I'm going to add these 2 numbers and get 7. And then I'm going to add these 2 numbers here, and I'm going to get 16. I'm going to add these 2 numbers here, and I'm going to get 31. It's not 31, 21. And then I'm going to add the 7 to the 21, and so I'm going to get 28. I'm going to add 7 to that, so I'm going to get 35. I'm going to add 2 more, so I'm going to get 37. I'm going to add 3 more, and I get 40. And as I said before, this very last row should have the number of data pieces that I started out with. Now, the relative frequency is 2 divided by 40, so that's a ratio. So this will be 2 divided by 40. This would be 5 divided by 40. This would be 9 divided by 40. And then 5 divided by 40, 7 divided by 40, 7 divided by 40, 2 divided by 40, and 3 divided by 40. Now the cumulative relative frequency is now the summations, kind of like I did with the cumulative frequency. So I can write this as 2 divided by 40, or I can do a decimal, 0.0500. And then the next one I'd be adding to it. So I would add 2. So right here, I'd be adding these 2 together as decimals or as fractions. And so I get 0.1750. And I would continue this. So I'm just going to go ahead and continue putting these numbers in for you. And you should be able to verify this on your own. In fact, the next one I'm going to be doing is you will be putting these in on your own, and you're going to make sure that you are getting the same numbers as mine. Oh, I missed a number. So 5250. And then this one should be 0.7000. And then 0.8750. And then my last one is 0.9250. And then this last one, like I said before, this should be in this last row, 100 or 0.1. Now, I'm going to let you do this one on your own. So go ahead and pause it. Make sure that you are getting the same numbers. I'm going to put the numbers here in a moment. So go ahead and pause it. Come back to me in a moment. Welcome back. Make sure that you are getting the same numbers that I've got. Hopefully you did this on your own. So now they're going to ask me what is the class width of researcher A and researcher B. So if you take a look, my class width here is, I go from 36 to, not the last one, I go from 30 to 36. Notice I ignored the decimal. I'm going to ignore this last one because this last one is odd in the fact that it does not have the same class width as all the previous ones. But the reason that they did that is, would be my guess, is that they wanted to have the same number of classes as the previous one. And when they made this class width, this is different than what I would have done, is that this one ended up having to have a slightly larger bucket. Now, let's take a look and make sure that the other one has, nope, see, the other one actually doesn't have, has a same size, but this one doesn't. So again, I'm not certain why they did this, other than the fact, and I'm going to say they, is I got this example out of our book, the OpenStax book, is I'm assuming that whoever wrote this, rather than having a consistency as using the same class width, is that, or the same buckets, is that this made more sense for the data. I don't know. I honestly don't know why they did that. I would not have done that. If I would have had nothing in the bucket, then I would have had nothing in the bucket or that class. That's what it is. So anyways, back to the question. The answer is 6. So the class width for both of them is 6. Now, if they want our boundary for researcher A or researcher B, then I'm going to go to my very first class, which was, if I look at my very first, or what do they want it on? The second class. So they're asking me for the second class. So I'm going to go here and I'm going to have the 12.4. That's my upper limit of the class 2. And then I'm going to do 12.5, which is the lower limit of my class 3. So my class boundary is going to be the 12.5 minus the 12.4 divided by 2. And then I'm going to add that to my lower class limit, which was 12.4. And so I have 12.45. So that's where I will make the cut mark. So if I had something that happened to be 12.45, I would put it in that second class. If I had something that was 12.46, I would put it in the second class. Same thing similar to the third class for researcher B, it is 18.4. So determine what key data terms refer to for researcher A. And so we are looking for values of X, such as 3 months, 4 months, 11 months, and etc. Why would this data differ? Excuse me. Well, one of the reasons may be the average age of the individuals in the two samples. So one sample may have slightly older people in it versus the other one. So we don't know anything about the ages of the people in the groups. And it could be that one of the groups have more women than men in the group, or maybe one is all women and one is all men. We don't know any of that information. We just know that the data is different. And so the question is, can you tell if one researcher is correct and the other one is incorrect? And the answer is no, we don't have enough information to make such a claim. All we have is this raw data. So all we can do with it is put it into buckets and talk about frequency and the spread of the data. We don't know anything about the groups that it came from. So we don't have enough information to make any kind of claim about who is right and who's wrong. Since we don't know enough about the treatment group, we don't know why there's differences. And we can't make a decision about why the data is not identical, right? We don't know. It doesn't necessarily mean that the treatment has no effect or is not effective. So just because it's not identical does not mean anything. We don't have enough information to make any kind of judgment on it. And I know statistics is all about making judgment, but until we know more about the study, who the people were in the study, we couldn't make any actual judgment, other than the fact that we could say researcher A had mean, median, and mode, which we'll talk about. We'll talk about the center of spread about the data, and researcher B. And then later in this class, when we do hypothesis testing, we can get more information and make more decisions. Suggest at least 2 methods the researchers might have used to grab the random data. Well, we can take a simple random sample from each group. That's one way. We can assign a number to each patient and use a random number generator to select each patient. We could do it that way. Suppose that the first researcher conducts a survey by randomly choosing one state in the nation and then randomly picking 40 patients from that state. What sampling method would he have used? He would have used simple random sampling method. Suppose that the second researcher conducted a survey choosing 40 patients he knew. What sampling method would the researcher use and what concerns would you have? So this would be a convenience sampling. It's not random. And maybe the second researcher chose people he knew that were already healthy to begin with and is showing very little symptoms, and they're all very young. And so that would have a biased outcome to their data when they collected it. So that's it for this video, and we'll see you in class.